Hello, anyone that's watching. This is my pretty useless but working space plane. Useless because all it can really do is carry Kerbals, nothing else. Maybe a few more kilos for some snacks. It's working because it will get to orbit and back, and theoretically it's reusable. Neither the drop plane nor the space plane are particularly aerodynamic. They are aerodynamically stable and actually fairly clean shapes, just pretty bulky. They rely much more on brute force than being slippery through the air. The drop plane could definitely be improved. My main focus was on the space plane, though. Trying to get that into orbit. So there's a lot of room for improvement on the drop plane still. So rotation was around 130, 40 meters a second, which isn't insane. Like Concorde was around 100. The real insane part about this is the Mach 3 drop. Accelerating up to that, and aerodynamically, thrust wise, is a bit. It's asking a lot, realistically. But in KSP, I managed to do it with a load of J58s, and I didn't worry too much about aerodynamics. I put a lot of auto struts everywhere and hope for the best, and relied more on thrust than aerodynamics. Start the drop, turn on the Raptors on the space plane, and then turn off most of the J58s on the drop plane. Drop, try and keep it flat for a second, stable out, and gain some speed. Put on the nuclear engines, start pitch up. So I'm trying to get the pitch up as much as I can in the beginning. So 30-ish, 30 degrees is what I'm aiming for. Just so I can get out of the atmosphere as quickly as possible and save some fuel. Because it's not that aerodynamic now. Dropping from this height, I found you needed about 8.3 kilometers a second of delta V. It just about gets you there. I'm using 2 Raptor engines and 2, I think they're Instar nuclear engines. Originally, I tried lighting the nuclear engines one at a time to save fuel, but they just didn't produce enough thrust once the Raptors burnt out, and it ended up struggling to gain enough speed to reach orbit. So instead, I'd light both the engines right from the start. They don't contribute much at sea level, but they do add a little bit extra thrust throughout the climb. By the time the Raptors run out of fuel, the Spaceplane's already travelling at around 6 kilometers a second, so that gives them a lot better of a chance to get to the rest of the way to orbit. The flight profile is also really important. If you waste fuel climbing too steeply or making unnecessary maneuvers, you're probably not going to make the orbit. So throughout the ascent, I'm constantly watching my pitch angle, my speed, and my time to periapsis. I start around 30 degree pitch after release, then gradually lower the nose and altitude increases, trying to keep my periapsis at roughly 1 minute. And that way, I'm building horizontal speed as efficiently as possible without sending my apoapsis too high too early. It's a bit of a balancing act, but after a lot of trial and error, this ended up being the most efficient flight profile I could find. Another thing to watch out for is the direction you launch into. It sounds really obvious, but I was not checking that in the beginning. I was launching into retrograde like an absolute knob. I kept getting really high, running out of fuel, and barely reaching 7 kilometers per second. It was incredibly confusing until I realized what I'd done. But it's actually a great demonstration of how much Earth's rotation helps you. If you launch east, the Earth is already giving you a few hundred meters per second for free. You launch the other way, instead you're getting that against you. So when you're trying to squeeze every last meter of second out of something, that makes a huge difference. So we're just at orbital speeds now. I actually ended up pushing my apoapsis to over 400 kilometers by accident. Ideally, I should have shut down the engines a bit sooner, but I really wanted to make sure my periapsis was positive before I did. And like I said earlier, I'm definitely not a professional scientist or anything. This entire project was basically one big exercise and trial and error. Once I was in orbit, I thought I better do at least one orbit before coming back down. but I think I'd only put one battery in, so I wasn't entirely sure I'd have enough electric to do the orbit and still be able to move after, but turns out just about had enough. After completing an orbit, it was finally time to see if I could get this thing back to Earth. Using the reaction wheels, I pointed the plane retrograde and fired the engines just for a few seconds, lowering the periapsis to around 85 kilometers, which seemed to be around the sweet spot for atmo bouncing and not bouncing. So getting into re-entry now, entering the atmosphere, and the design to make this work for re-entry was definitely the hardest part of the whole thing. I learned pretty quickly that anything with a sharp edge or point heated up instantly and blew up. Every time I thought I fixed the problem, something else would burn up. And in the end, I had to make almost every leading edge as blunt as possible, spread the heat out during re-entry. The downside of that was that it wasn't exactly helping my ascent because of the blunter shapes and the drag, but like pretty much everything else with this, and anything that's trying to do like a multi-purpose mission or whatever, is you're always compromising on something. The shape's great for getting into space, isn't usually a shape you want coming back down again. The next problem was actually keeping the thing stable during re-entry. As the atmosphere got thicker, the spaceplane would slowly start yawing, and before long I'd spin completely out of control. And after a lot of experimenting, I eventually found a solution. I angled those top tail fins slightly inwards, gave it a bit of a V shape, and I added a load of fins under the wings, which I was inspired by surfboards. Now, whether it's exactly the same physics or not, it worked, and the plane stayed much more stable through re-entry, and for the first time I could make it all the way through. That little explosion, that's normal. That was the ullage thrusters, and I only added them right at the end of the build just to make sure I didn't have any fuel settling problems whilst I was in orbit trying to do the deorbit burn. It turned out I didn't actually need them, so I didn't care that they blew up. The other thing that did explode though, which was a bit more annoying, was the reaction wheels. I'd placed them like after the Raptors, but on the Raptors, and with the move tool I moved them in front of the Raptors so they'd be inside the fuel tank and out of the way. But I guess KSP still considered that to be outside and getting the brunt of the heat or something. Because they both blew up whilst nothing else blew up, which was odd to me, but that's fine, they're cheap. Now we're getting into the most extreme part of re-entry, and for a bit of reference, a space shuttle used to fly through this part of the atmosphere with an angle attack around 40 degrees, and it would also roll from side to side, stop it bouncing back off the atmosphere. My spaceplane wasn't nearly as good, so I couldn't really keep it much above 14 degrees without it becoming unstable. So my solution was, for the space shuttle, it used to come in with a negative periapsis from orbit. Mine, I had to go for around 85 or whatever it was, 85 kilometers. And so I'd basically just be skipping along the atmosphere for as long as possible. It was a lot of trial and error. I had to figure out how deep I could go without burning up, and then how high I could go without skipping constantly. So this one was quite a good compromise again, and it worked out well. Now, for the landing, I wanted to make it as real as I could, as I didn't put any landing gear on to try and save weight. So I thought I'll do a sea landing, you know, like some planes land in the sea, and I'll get as slow as I can, you know, basically hover over and see. So, yeah, 60-ish meters a second, hit the water. I thought that was pretty good. Turns out that's like 240 kilometers an hour. So, not that great. Especially to a stop like that. Anyway, taking the heat shield off now so you can see where I've stuffed the Kerbals. Just gotta let the sea wiggle it off the tip. There we go. Come on. There. And there they are. I just stuffed them inside that fuel tank. It's like a hollow cylinder. They're comfy.